Alright, so what we're looking at here is an oscillating slinky. Josh is going to be oscillating this at the fourth harmonic. And we know that the fourth harmonic should have 5 nodes and 4 antinodes with 2 full wavelengths within it. So let's watch this first and let's see actually if we can notice the fourth harmonic in the oscillation. So there it is oscillating perfectly. Okay, so we stop it. And we know that they were oscillating back and forth due to the motion there. And now let's take a look and see if we can sketch this in. So here is the slinky, and it's one point in time. What we'll do is we're going to run it again and see if we can't catch it in another spot. There we are. So a couple times I stopped it in the same part of the oscillation, as you could tell, but now we're looking at the other part of the oscillation, just on the other side. You can see clearly now. You notice they're getting smaller, but that's more because of the perspective than anything else. Now if we run this, we should be able to see it just oscillating back and forth, with the nodes being in these spots here and the antinodes being the spots of complete constructive interference. And there you go. You can see them fitting perfectly within that throughout the whole thing. We'll bring it back just to watch it again. And there you go. You see them oscillating within those ranges. Okay, there I've caught it right in the middle, which is interesting. Alright, so there it is in its oscillation. So we know that the antinodes are here. And there's another one here, so that's 1, 2, 3, there are 4 antinodes, and the nodes themselves, as you can tell, there's a node there, there's a node here, a node there, and another node here, areas where there's complete destructive interference, and one at Josh's hand. So we have 1, 2, 3, 4, 5 nodes, and we have 1, 2, 3, 4 antinodes. Now what's interesting here is that we know that the distance from way over here all the way to here, we know that that distance, we measured it out, is 5 meters. So if that's 5 full meters from there to there, then the distance for one wavelength, and I'll sketch one wavelength in. One wavelength goes from about, let me just figure this out here, one wavelength goes from here right to there. So it ends at that point right there, and it started there. Of course, there's another wavelength happening over here. So if the full distance is 5 meters, and half of that distance is one wavelength, then in fact, in this case, one wavelength is equal to 2.5 meters. And that means the other 2.5 meters is over here. And that's the fourth harmonic oscillation.